Our next session is a conversation with two extraordinary innovators. Let me not steal the thunder of our chair by telling you all about them, but suffice to say that Tony Fadell and Russ Garcia, I know, are about to get your minds racing. Our questioner for this session and our conversation stimulant, if you like, is the deputy news editor of the Financial Times, Alice Ross. Let me just say one thing about Alice. Alice is, as well as being the deputy news editor of the Financial Times, is the author of Investing to Save the Planet, highly recommended in the cogX bookstore, but also highly praised by Christiana Figueres, by Al Gore, by Richard Curtis. The list goes on. So indeed, she will be asking the questions, but Tony and Russ are standing by. But let me leave you. The next voice you'll hear will be that of Alice Ross. Thank you, Alice. Over to you.
Hi, thanks so much for having me. Well, I'm really delighted to be chairing this session because, as mentioned, I have written a book recently called Investing to Save the Planet. And the reason I wanted to write this book was because I was coming across so many great ideas of how technology can be used to combat climate change. And I was coming across a lot of people in startups, creating companies with just really fascinating technology, things that you had never heard of and that could make you feel quite inspired about the kind of things that that people are coming up with. And of course, investors are very interested in this space, and there's so much money going into these kind of great ideas. So that's why we're here right now, is to hear about one of these specific companies, which is really great. So I'd like to introduce Russ Garcia, who is CEO of Menlo Micro, the company that we'll be discussing, and Tony Fadell, who is principal at Future Shape.
Hello.
Hi.
Hey, everybody. Hi, Al.
Well, who would like to start? I mean, the first thing that would be great to know is a little bit about the company and how the technology works. Some of the details of that would be brilliant. So Russ or Tony, I don't know who wants to go first on that.
Russ, take it away.
Yeah, I'll introduce the company. So Menlo Microsystems was a technology that was spun out of GE 4 years ago, or more than 4 years ago, where basically through material science, we've reinvented the electronic switch. And as you know, switches are in virtually everything. And the entire background of the company started with GE engineers who were looking to basically reinvent the circuit breaker. If we look at switches and in all of the applications that they're used, whether they're an electromechanical switch, those haven't changed in over 140 years. And basically the transistor was invented 70 years ago. And so we've basically taken the best of both of those things and come up with a device that is far more efficient in switching power and switching electricity, in switching wireless communications as well.
And can you give us an idea of how widespread this could be if this really changed the switching technology? It's not something, I have to confess, that I've ever really thought about before. So that's fascinating that it's in everything and it hasn't been updated for decades.
You can think about it just in your smartphone. There's at least 20 switches that are tuning the antenna to get you better reception. And in a 777, there's hundreds of thousands of switches. In your car, there's tens of thousands of switches. And you start thinking about your home, everywhere from the circuit breaker on the side of the house to all of the light switches, to all of the switches that are in every single appliance in your home or in your office. And so all of the energy that we use is distributed through those switches. And so the efficiency of those has a huge impact in how energy is used and how communications is done.
So Alice, let me just chime in here. So just to be clear, in the US last year, over 60% of all the energy generated was lost in inefficiencies. And some of that, and a lot of that, goes through switches. So think about 100% of the energy in the US, and it's even bigger worldwide, of course, 60% of it is just being thrown away in inefficiencies from the time it was generated at the power plant or wherever, all the way to the place where we consumed it. And so we talk about getting to green energy and these kinds of things. Well, we could do that. That's great. But how about saving the 60% of inefficiencies we have in the system? Could you imagine if we could go green much more quickly because we only need 40% of green energy and the other 60% is saved? That's the kind of thing, everyone's like, oh, batteries and, solar and wind and all that stuff. People don't look at the systems. They think they work really well. And frankly, they don't. 60% is wasted.
It's so interesting, the psychology of that. I think when VC investors are coming to these kind of climate change things, apparently one of the first things they think of is something consumer related, something that relates to their lifestyle. So they want to invest in electric vehicles because they might have a Tesla, or they might want to invest in Beyond Meat or something, some kind of alternative food because they might have gone vegan. And whereas actually energy efficiency is such a massive problem, but it sort of doesn't seem sexy in that kind of way. So it's not the first thing that investors think of, complicated, switching technology. But, of course, it has a huge, huge role to play. And, if you can get the technology right on it, then that's brilliant. Are there other people out there trying to solve this switch technology thing as well? Are you the only guys, or are there lots of people working away on it at the same time?
So that's a great question. It's really interesting because I think, first of all, the sexiness of it, when we first started trying to raise money for this over 5 and a half years ago, it was really hard because you went in and investors would look at you and go, a switch? Why do we need a switch? We have switches. And until they start understanding that what's behind this is a material science, and yes, others have tried this, and many others have tried this. But the material science behind this, basically, what GE did was they were actually trying to source this. In sourcing it, they found out what the problem was. Is there was a reliability problems, there was electrical efficiency problems, and basically they took the metallurgists that designed the metallurgy for the fins on aircraft engines and combined them with the semiconductor device folks. And we now have a material science chemistry that allows us to make this switch. So we have a huge efficiency in how we conduct electricity, but we're also able to make this mechanical device in what would typically be a semiconductor technology. And so we can make it, as you can see, I think on this, I believe the slides are up here. You can see we can make it 99% smaller than what an electromechanical device is today because of that material science.
Mm.
So let's be clear. 40 years people have been trying to solve this problem. 40 years. And this is the first company that's actually been able to do it, and it's already in production and shipping. A lot of times we're talking about these new technologies and new companies, and maybe in 4 years they'll have something, maybe in 3 years. We're actually in production right now and shipping, and it's been many years of getting here, but it feels incredible to actually to have them in production. We should actually go if we could fast forward to the slide to show people what it looks like. Yep, there's switches, lots of switches in all of these things. Switches. Let's go one there. This is what we're talking about. That's the ideal switch, the Menlo Micro one, that little tiny box, that little tiny rectangle, looks like a piece of gum, but it's smaller than that even. And a relay, that's a typical relay that are sold in the billions per year. We replaced that big old unreliable switch with something that's more or less solid state. It's a micro electromechanical system, a MEMS switch. And so that's really telling. And if we go to the next slide, which is the other form of it, if you look, there's another form of switch that's an electromechanical switch, or a silicon switch, solid state relay. But you can see all those fins on there, and you see that black thing underneath. That's all heat, because it's so inefficient that it generates so much heat that it has to push it out through a heat sink. Whereas on ours, you don't have to have any heat sinks whatsoever. So because we're so efficient, you have amazing benefits of both a relay and this solid state relay. And so this is what's so dramatically different. So think about all those big things in the world, and we can replace them with, it's kind of like moving from vacuum tubes to transistors.
Well, Tony, I mean, how did you come across this in the first place, and what made you interested? You know, how did you sort of see through the potential unsexiness of this and think this is a really great idea?
Oh, well, that's where it all becomes really interesting. So at Nest, a company that I founded 10 years ago, or we actually 11 years ago now, one of our biggest things, we were making a thermostat. And if you have a thermostat in your home, you probably hear it all the time. It goes click, 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 click. It's always turning on and off, depending on the time of year. And so that's a relay. It's one of those things you just saw, the picture you saw. And so there's relays throughout your house controlling your heating and cooling. Well, I hated the noise. I hated the fact that they were big and bulky, generated heat. So I was looking for another alternative that wasn't a silicon switch, a transistor. And we couldn't find anything. I said, in all of these years, we can't find something that's better. And so we ended up putting in a transistor, and then the transistor started blowing up. So you have to also understand that doing high voltage or power types of applications, silicon or transistors can blow up very easily. And so, and be destroyed in the field. So we had this problem where we couldn't use relays, we used transistors, but they were only so effective. And I looked around the world for technology, and then I found it at GE, but Menlo Micro hadn't been found yet. So I found the technology, GE wasn't doing anything with it. And then ultimately I just kept watching and watching, and a few years later, GE decided to make a company out of it called Menlo Micro, and I was the first investor. I called up Russ, like, Russ. He's probably like thought it was crazy. Some investors like wanting to go in. I was like begging him, please let me invest.
That's a nice problem.
That was a wonderful phone call. I'll tell you that, because it very seldom get somebody of Tony's stature to call you up and say, "Can I invest in your company?" Well, let me think about that. Sure.
And so it was really great to see what they were doing and how important it was. I knew what it was fundamentally because we at Future Shape we invest in over 200 companies. Like you were talking about these interesting companies that are going to help save the planet, and so we see companies all the time. And Menlo Micro is one of the standouts. And when we see these companies that we know can fix the planet, help fix the planet without making us go back in time, and stop using the things that we like to use, then we're like, this is gold. We have to help them, because most investors won't help them. As you know, maybe that's going to change now. But 5 years ago, as Russ said, most investors turn a blind eye, go, too complicated. Who wants this stuff? That's the stuff we love to do.
I mean, I think one of the themes here, as I understand it, is something that is referred to as the electrification of everything. Can you explain what that is and what that means in this context?
Sure. The electrification of everything. Look, we're seeing all mobility, whether it's cars, trucks, buses, garbage trucks, whatever, they're all moving electric. We're seeing many of our other appliances around us or power generation all moving electric only. Everything's going electric, everything's going wireless as well. And when you go electric and you go wireless, that means lots of switches, even more switches than we see today. Switches are like paper clips. They're everywhere, but nobody sees them, right? We all use them, but we don't appreciate how simple yet important they are. And so as we move more and more to the electrons of everything, more and more of these switches are going to happen. So we don't want to have more inefficiencies in the system. So we add more and more power. Could you imagine? We move more and more things over from electricity or energy usage, and then all of a sudden we have to generate 2 or 3 times more power because of all the inefficiencies of this system just to power the new products that are becoming electrified. So we're going to try to make sure that those inefficiencies go away, at least a portion of them, for what we can handle. And it's a lot of inefficiencies in switches.
Yeah, just to add to that, the key to this thing is we've got to make them not just small, not just efficient. We have to make them small, smart, and efficient. And all 3 of those things are really important. And that's what we bring to the party. Whether you're, you can look on this slide here. That's a circuit breaker box on the side of a building or the side of the house. when you look at how the size that you could move that to, and then as Tony said, bring 40% more efficiency to the electricity you're switching through that building, and now you also do it smartly, so you can manage it, so you control it from a computer or from your iPhone or whatever the case may be. And now you start applying that not just to homes, not just to industry and manufacturing, not just to transportation, automotives and airliners and all those things. You start seeing the plethora of applications that it fits into everything, because we use switches for everything.
And we spend a lot of money on power, and we throw a lot of it away. If we could actually, save that power, changing out your circuit breakers or what have you to save power. It sounds totally illogical, but it's actually the case.
We did a back of the napkin calculation on, just in the US alone, there's 20 billion light sockets. If you put this switch into every one of those light sockets, you could save, and made them all smart, you could save 11 coal-fired power plants.
Wow.
When you think of that, it's kind of mind-boggling, right?
Yeah, so it could have a really big impact. I mean, it's interesting. A lot of the discussion we've been talking about making things more efficient and sort of replacing, old peaking systems that need to be modernized. But as I understand that, there's also, this technology could also make things possible in the future. Technology is about to take a giant leap forward. We've got AI, we've got 5G, we've got the Internet of Things. How is this Menlo micro product going to create possibilities and create opportunities, as well as fixing inefficiencies?
Well, in all of those things, we already are starting. So you start looking at whether it's AI and edge computing and cloud computing and data centers, for example. The amount of power that's required to digest, transmit, and operate on all of that data is enormous. You need switches, you need power plants, you need power distribution services or capabilities to be able to run those things, and adding those efficiencies to that. And the automotive side of the thing, charging, we've got to lay out complete, and that started, but there's a long ways to go. There's complete infrastructures of charging systems that need to be that need to be implemented across multiple countries, right? And so these switches will enable those devices to become better, right? I have a Tesla. If I'm driving across country and I need to charge up, I've got to sit there for an hour in order to do it, right? So how do you add efficiencies and add capabilities to allow that to be 15 minutes? Now, we don't do that by ourselves, but certainly in conjunction with battery technology and enabling that to become more efficient as well.
Sorry, my cat likes to attend these regular guest. No, that's brilliant. Sorry, just moving him. So where were we? Hang on a sec. Sorry. So in terms of the environmental impacts, I thought that was really interesting. I mean, could you say a little bit more about, you were comparing it to saving energy in terms of 11 coal plants. Could you calculate how it will fit in with the US goals at the moment in terms of being net zero, things like that? How much of a role could this play in those government goals to cut emissions?
So I'll start off, and I'll let Tony add to this, because I know he's got a lot of color on this part of it. But if you just even what we started the conversation with, a 40% savings in distribution, in how much time is it going to take for all of the renewable sources of energy to, and as we said at the beginning, not that we don't need to do those things, but they're going to take a long time in putting those infrastructures in place. This switch can be retrofitted into various applications across the distribution network of power, and so you get the payback of that 40% gain much quicker than changing the source of energy. And I think that's the really big application. And we're already seeing it just in a different way in communications as we start applying this to 5G and more efficient communications and how bandwidth can be improved with this kind of switch, which also relates all the way back to energy. But the distribution capability, I think, is going to be the first big impact.
I agree with you, Russ. And if you look at 5G, we're going to put on this planet 5 to 10 times more cell towers than we do today. We're going to put in order of magnitude more cell towers. Those are already, the ones that are installed are highly inefficient from a power perspective on the RF side. You drop in ours, you know, as you can see in the slide again, you save that 40% power right there, and you get better actually reception. You may be able to actually put less cell towers out there. So just think about that infrastructure alone that's going up and how inefficient it was going to be and now how efficient it can be. And to Russ's point, this can be retrofitted into so many things, so we don't have to go through all of the CO2 production, everything else to make new planes, make new cars. We can retrofit this into houses, into cars, into planes, what have you, to get these inefficiencies right away. Wouldn't you like to have, you know, a 20% better, you know, battery in your car without having to buy more battery or tear up more land, you know, for lithium mining or cobalt mining or what have you? This is, you know, this is a very opposite way, different way of thinking about attacking the problem. And what's so great is you don't have to have all new products to take advantage of it. You can drop it into the existing ones. And it's amazing the size and cost and reductions as well, not just the power savings.
Yeah. Russ, I mean, maybe you can tell us, we were talking about how advanced the company is relative to other companies, perhaps at this stage where you're already producing, you know, you're already shipping. What's the sort of the 5-year plan for the company now? Where do you want it to be in 5 years' time?
Oh, well, I want it to be much bigger than it is right now. So the last 4 years has been a lot of work, as Tony mentioned. It's a material science play, and so hard tech has a lot of hurdles to get over. We've been getting over those hurdles, and we're now.
There are a lot of hurdles.
You know, we're very early, and we've been designed into over 60 applications and 60 different company applications so far, and they range from primarily communications today, but a lot of them, a lot of the new power ones are starting up. We've just are developing some new optimized power products that will become the larger portion of the company as we grow here. So we plan on being in, you know, I don't like to say real numbers in a public forum like this, but you know, tens of millions of dollars of revenue here in the first year of production, and that'll grow substantially over the next 4 or 5 years, where you'll start seeing us in we have over $20 billion of market SAM that we can go after with this, and
the only thing that's stopping us now is we need more manufacturing capability. We have to find more manufacturing. So if anybody out there in the audience has got manufacturing extra manufacturing space for MEMS, no, I'm not kidding.
Yes,
that's how much demand we have. We got to get more manufacturing up and running. But I saw there was a couple of questions.
Yeah, no, I was just going to say it's probably a good moment to move to the questions and talking to the audience. So I guess we can all see the questions, can't we? So maybe you don't need me to read them out. But I mean, we can go with the first one here. So this is from Rose Simnet. As the energy mix becomes more varied, how will these switches support a reliable energy flow? That's an interesting question. So as we're moving to, you know, renewables, and we're going to have a transition period, certainly, where we've got all sorts of different things going through the grid, how's that going to work?
Well, I'll take this one, Russ. How's that?
Okay.
So the thing to know about these, you know, most of the switches, like let's just take switches on a plane, okay, on an airplane. Those are only rated for a few thousand switch, you know, activations, you know, 10,000, 20,000 activations total. So turning it on and off each time is one time. And you have to replace those every 6 months by FAA or every year. You have to replace them. These switches switch 3 to 4 billion times. So we're talking orders and orders of magnitude. So if you want more reliable energy, you want more reliable switches in the middle. Usually it's not the wires that break unless it's a weather event and something cuts them or something like that. It's usually the switches or something that's in the power distribution that fails. And so when we're talking billions of switches compared to tens of thousands to possibly 100,000 switches, it's a whole dramatic different, scale of, reliability that you have with these kinds of micro electronic mechanical switches.
No, that's great. And we've got two questions from one person here. They're quite different. I think we'll do them one by one. And I would just say, if anyone else has any questions, do send them in now that we're in this portion of the talk. So this is a question from Mohammed Hamza saying, how will the impact go beyond developed economies? So we've been mostly looking at the US as we've been talking here. Is this, but presumably it sounds to me as if this is something that could be used really in any economy right now, or is it more suitable for developed economies at the moment?
Well, obviously developed economies adopt things faster like this, but one of the keys to this is the scalability of it. When you look at that slide we showed earlier with the electromechanical switch that really has not changed in 130 or 140 years, some of those are actually still have hand wound coils on them, so they don't scale, and that's been one of the inefficiencies besides the efficiency of the electricity is the ability to scale it. So the key to us is we get all of the benefits of an electromechanical device and all of the good electrical efficiencies, but at the same time we scale like a semiconductor. And that's what that slide where we showed the really small chip there is. We can get tens of thousands of these on a small wafer, which is going to allow this to be a far more economically feasible technology to then embed into the applications, whether that's infrastructure or automobiles or applications like phones, etc.
Okay. And then another question also from Mohammed Hamza is, what does the cost curve versus adoption look like for this technology? Bit of a technical question for you there. I don't know who wants to take
so today we're in very small volumes, and so the applications we're after are I'll say on the higher end of the scale. However, our cost structure is already better than those applications. As we continue to add volume, it will allow us to scale into more cost-effective applications. But for the most part, we're attacking cost is not the biggest issue for us. The biggest issue for us is reshaping the application to accept the switch. A lot of these things, and when you think of an application, we have some applications where we're designing into where we've shrunk the size and the weight by over 90%, and so it's really easy to grasp why you would do that. But then when you realize that there was this big giant box that was going into an application, and now it's this little tiny thing that now I have to reshape the rest of the box before the application makes sense again. So that's actually the bigger issue than the cost piece of this.
Okay. Yeah.
But the cost, it's Moore's law. We're there. It's just a matter of, as we said, getting the volumes up and everything else. I don't think anything, frankly, to tell you the truth, I will predict, and I hate doing this, but I will predict the death of the relay within 10 years. There will be no more of those relays that you'll see anymore. Kind of like, okay, sorry, vacuum tubes are still around for certain audio applications and stuff like that. But I think relays are going to be almost there in 10 years, 15. Hey, honey, I'm not, okay. No, not now. Sorry.
Kids and cats in this.
Kids and cats. They love switches. Oh, and then also on the developing world, just to be clear on it, all the developing world's putting in 4G and 5G everywhere, right? They're putting wireless point-to-point links because they don't have fiber optics. They're trying to get off-grid energy, so solar. When you get solar to batteries, you still have switches. And the last thing you want is to buy more batteries and bigger solar panels when they're going through inefficient switches and inverters and things, which we can also do. So everywhere that's going to put any kind of infrastructure that touches electrons, RF, wireless, or electricity, whether it's in high GDP countries or low GDP countries, this works. And that's what's astonishing and so great, and so glad that no other investors were really interested 5 years ago in the company. And now it's great now. Everyone's going to be piling in and have been.
On that question of being the sort of the first person in the game, is this a good area to be the first market mover? Sometimes you hear it's best to be the first, or it's better to be the second.
In this case, it's better to be the first, and because if you really look at this, for us, a lot of the greenfield is installed base of switches that already exist. We're just making them 10 times or 100 times better in many cases, and so the applications are there. It's not like in that argument. Somebody invents something new and it has to get adopted, and then the second person in makes it more efficient. These switches have been around over 100 years, and so we start with a really big greenfield of installed base.
Let me come from a different direction. We did not have production parts. We didn't even have sample parts. We already had signed up customers on the dotted line who were wanting to give us checks because there's such a pent up demand. Just like when I was at Nest going, I need something like this. And people have been searching for it for years. And we finally brought this thing that's the best of both worlds together. They're like, oh my God, how can I get access to it? So they're lining up. And that's why I'm saying they're continuing to line up, because they're like, I need this stuff. And so we don't have to tell, the applications that already know better. They've already been looking for it. It's like they stumbled on a pot of gold and they're like, oh my God, I finally found it. Because they've been searching for it, right? They've been searching for treasure for 40 years.
That's great.
That's what's so great about it, yeah.
I mean, speaking of people lining up, we have another question, and this may actually go to your plea, Tony, which was for people with manufacturing capabilities to get in touch, because we have a question from Antrix Gautam asking, would you also look at manufacturing in Europe and Asia? I think we've been looking at assuming that it's being done in the US. Do you have the capability to expand? Do you see the company going in that direction?
So today we actually manufacture in the wafer manufacturing is done in Europe today, and actually our back-end packaging is done in Asia. For expanded capabilities, we are looking at both Europe and Asia, as well as the US. I think right now we'd like to have some US presence in addition to the European and Asian presence that we have.
Okay, so possibilities there. We've got a question from John W. Lewis asking, what is to stop any semiconductor vendor from doing this?
So this is a great question, because the list of companies that tried to do this in standard semiconductor technology is very long, and it was hundreds of millions of dollars of investment, and virtually all failed.
Wow.
They're not everybody, but virtually all failed. What we've done different is, and I think I said it 2 or 3 times, Tony loves this about the technology as well, the material science behind it is the key. So I'll put it this way. You could not find our materials and our chemistry in a fab today, but what we have is fab friendly. So in other words, we have a proprietary material set and a proprietary chemistry that allows us to make these switches. GE spent almost 15 years and $50 million of research to develop this. We've raised upwards of just under $80 million to date as well, and spent another 4 or 5 years putting it into a commercially producible state. And it's a tough road to hoe.
And don't forget all of our patents.
And yes, we have over 60 patent families surrounding the core technology as well as the applications it works in. So you know, enough time and enough money. I'll say that most anything can be replicated, but this is I truly believe the greatest invention of component technology since the transistor, and it's very fundamental in nature.
I have to say, I didn't think I could get excited about component technology before, but now I am feeling excited. So I'm convinced.
You got to see it. It's an incredible thing when you see the results. You know, it might not seem like everything changes around you, but it really does change.
Yeah, amazing.
It's really cool.
Well, we've just got, I think we've got about 1 minute left, so we don't want to go over our time. I'll just say, you know, Tony, any further thoughts on this, whether it's this technology or anything else that you're looking at while we've got you, might be quite interesting to hear about.
Just to all the investors out there and to the entrepreneurs out there, it is a market difference in terms of companies like Menlo Micro who can get out and get funded now compared to 5, 10, 15 years ago. It is a wholesale switch over, and people are now, and investors and entrepreneurs are now attacking the space. Stuff that's unloved for years, like the relay and this switch technology, unloved for years, is now able to get there because it's so impactful to what we need to do from a climate change perspective. And if you can show the real value, it's coming. So I encourage more entrepreneurs to get out there and do these things. If you're looking for money, please come find us at Future Shape. This is exactly what we love to invest in. And, you know, just why, and if you're building anything, make sure you go look at Menlo Micro stuff, because, you know, you should be doing the right thing for the planet. If you're designing anything that's new, you know, make sure you don't have the efficiencies of the old.
Yep. Okay, great. Well, I will say thank you to both of you, Russ Garcia of Menlo Micro and Tony Fadell of Future Shape. Thank you so much. That was really interesting.
Great.
Thank you. Thank you.
Thanks, Alice.
And thanks everybody for watching.
Thanks, everyone.